Last week, I gave an exam at TPS and was surprised by the results, begging the question, is 24 Alpha's performance on the exam significantly different from other classes' performance on the same exam? This was a good example of how to use the new large language model tools to enhance everyday productivity. And so I want to give you a quick demonstration of how I used ChatGPT to answer the question I had about exam performance. This would also work with NipperGPT, built on the same model, but AFRL is currently upgrading the Dark Saber servers, so NipperGPT is not currently available. So I've got the exam scores in a spreadsheet arranged by class. I am using Anaconda for my Python source. So we're going to start go ahead and start a new chat here. And I have an Excel spreadsheet, grades.xlsx, with exam scores for several classes. Each class of students is a vertical column. I want to read the scores into a data frame and create a box and whiskers plot comparing the grade distribution. Using Panda's box plot function and orient the box plots horizontally. Give me code to do this. Save the figure as box plot. I want a PNG at 300 DPI. ChatGPT turns away. There's code. I'm going to copy the code, go over to Anaconda, and we'll run it. All right, not bad. I do want, it makes more sense to me to have 20 alpha at the top and 24 alpha down at the bottom, so I want to reverse the y-axis. So ChatGPT tells me that the axis ax.invert y-axis will do that. So I'll come in here, run it again, and that's exactly what I want. So over here we see box plot, 24 alpha. So we can see there's some outliers here. Definitely the interquartile range is greater than what it was for the other classes. But is this statistically significant? Another natural question. So one of those tests is a Fisher's exact test. So now I want to build a 2x2 contingency table from the data frame. It's going to count the number of students scoring below 80, the number of students that passed, and then the number of students in all the classes besides 24 alpha that were below 80. So we will do that. ChatGPT is generating our code. We've already got pandas imported, so we will copy that to Anaconda, and we'll run that code. We'll just run this portion. All right, so there's our contingency table. 5 students below 80, 19 above. And then, so that's 5 divided by 24 students in the class. So about 21% of the students failed, and then 11 out of, so that 144. So 7.6%. So is that a statistically significant difference? We can come back to ChatGPT and ask, now I want to do a Fisher's exact test on that contingency table. We use SciPy stats. We'll get SciPy stats into the environment, and then we'll copy the code from ChatGPT. So there's our contingency. So we really just need this portion of the code, and we'll come back. All right, so there's our answer. 3 times, we knew that, 7.6% to 20.8% is a 3 times odds ratio. So 3 times greater, but statistically significant or not. And we can say if our p-value is 5%, we're actually slightly above that. So we're right there on the ragged edge of knowing whether or not 24 alpha was statistically significant from these other classes. So we can't reject the null hypothesis. But all of that, just a very quick way. That was less than 5 minutes to answer some very good questions, all with the help of our friend ChatGPT.